When we introduced definitions into our language, in essence what we were doing was giving you as the programmer the ability to create procedures that you could then abstract and treat as if they were provided by the manufacturer of the computer. The same way that you have addition and subtraction, you could create new variations of procedures and treat them as if they were behaving exactly the same way that those primitive procedures did. We want to do the same thing with data. We're going to talk now about creating objects, classes of objects that you can define as a user, and that switch is going to add a tremendous amount of power, flexibility, capability to our language and to our ability to create new systems. So let's see what that means. Let's start by talking about the objects you already know about. As you know, Python supports a number of different kinds of data. We've got integers, we've got floating point numbers, we've got strings, we've got lists, we've got dictionaries, a few others like tuples, but basically we have a primitive set of data objects. Each one of those examples that I have on my screen is an instance of an object. And every object has three pieces. It has a type, int, float, dictionary. It has an internal representation. It's a way of gluing together the pieces that compose the object. For primitive things like numbers, it really doesn't make sense to talk about it as anything other than a scalar. But for a list, it would say, how do I get the different pieces, elements if you like, of a list and glue them together? So every object has a type, it has an internal data representation, and associated with it, it has a set of procedures that allow you to interact with an instance of that object. We're going to look at some examples in a second, but those three pieces are key to defining an object. And indeed, every instance that we create is a particular type of object. 1, 2, 3, 4 is an instance of an int. If I define A to be, quote, hello, end quote, A is now an instance of a string. So we talk about objects as having types because that brings with them the ability to manipulate them. Okay, if everything in Python is an object and has a type, what does it tell us about how we might think about using them? And the first one is we want to think about each object as being a data abstraction. It captures an internal representation of the data attributes. We'll say what those are in a second. And it defines an interface for interacting with the object through methods. Think of them as procedures. And those methods define a behavior, but hide the implementation. Again, in a second we'll look at an example, but every data abstraction is an internal representation and an interface for getting to that internal representation, doing something with it, and then returning an answer. Associated with every object, we have the ability to create new instances of that type of object, and we have the ability to get rid of it, to destroy objects, either explicitly using del, which we know is a universal way of removing something from our environment, or just forgetting about them and letting the system eventually garbage collect or reclaim inaccessible or destroyed objects. But that idea of an object having a type, an internal representation, an interface is going to be really important as we think about how do we want to create our own objects. We want to talk then about data objects and that idea of internal representations and ways to manipulate them. We have some built-in data objects, lists, tuples, strings, and we're going to see examples of how they have both an internal representation and associated procedures. And we're going to take that idea and generalize it to look at the ability to create our own data object types. And that wraps back to what I said when I began. Once we can do that, we want to then treat those data object types as if they were provided to us and treat them as the same way we would treat any built-in data type. Let's look at an example to make this a little more concrete. This is an object of type list. It's an instance of a list. One of the questions we could ask is, how is it represented internally? Do you know? You shouldn't, because we haven't talked about it. And you shouldn't have to worry about it. You just want to use that data object through a defined set of procedures. It's possible inside your machine that a list is represented by allocating a sequence of consecutive slots in memory. The list would point to the first slot, that would be the first index. Incrementally, the next slot in memory could be the second index. Turns out that's not a great way to represent lists because it's limited in the ability to change them, to mutate them, or to have arbitrary sized elements inside of them. So in fact, the more common way to represent a list is using something called a linked list, where the list points to a cell in memory, actually to a pair of cells in memory, The first one of which contains either the object or perhaps even a pointer to an object elsewhere, and the second which points to or links to the next location in the list. It might be the next spot in memory. It might be somewhere else in the memory. And when I want to index into a list, I'm literally walking down the list, finding the right spot, and retrieving the element from it. That's a nice way to think about building lists. Is that the way you do it? Doesn't matter, because what you use with the lists is a set of procedures, a set of methods to actually manipulate the elements of the list. And you've seen lots of these. I can get out a specific element. I can slice into it. I can do it with a specific set of jumps. I can have procedures that actually compute things off of a list or get rid of an element of a list. I have associated with lists a set of methods. And there's that dot notation that we talked about earlier, and we're going to talk a lot more about in a few minutes. The key point here is I've got a set of ways in which I standardly interact with and manipulate lists. And from your perspective, you think about this. You don't worry about what the internal representation is because those procedures take care of that for you. As a consequence, that internal representation really should be private, meaning you don't know what's inside of it. And the correct behavior, in fact, could be compromised if you try and manipulate the internal representation directly. Ideally, you should always use the defined interfaces to get at portions of or elements of a list or any other data object that you've created. We're going to take that idea now and we're going to talk about how do you create your own objects and how do you use your own objects. And we've already seen we're going to need an internal representation and we're going to need methods to enable us to talk about how we want to manipulate that internal representation. To do this, though, we're also going to make one more distinction, and that's between creating a class and using an instance of a class. To wrap it back to earlier terms, the idea of a list is a class. But the example I had of the list 1, 2, 3, 4 is a particular instance of a class. And as you know, I could have many instances. I can use them in different ways. When we want to create our own objects, we need to do the same thing. How do we create a class? How do we make an instance of a class? Creating the class is going to involve defining the name of the class, so I can reference it. It's going to involve defining the class attributes. I'm going to come to that in a second. And an example of this is, in the list case, somebody wrote code to implement the list class, giving it the name list and defining the attributes associated with a list class. When I want to use the class, that involves creating new instances of that object, different kinds of lists, and then doing operations on those instances. So for example, if I have the simple list L is the list of 1, 2, then there's an operation on it. And that's operating on that particular instance, not on the whole class. I'm going to take those same ideas now and try and make them more concrete in terms of how do we define a class and how do we actually use instances of the class. But before I do it, let's talk about why. What I'm trying to do is now bundle together data into packages. That bundling includes linking together different pieces of data that are associated in one place, but it's also associating with it the methods that are going to manipulate that data object. And this is actually an idea we've talked about a lot because this is simply a version of abstraction. By doing this idea of bundling things together, I can now treat that bundle as an abstract data representation. To get into it, I need to define methods that can pull out pieces and do things with them, but I can treat the whole thing simply as an element. And that's also going to be really important as we think about building our classes. Second key advantage of object-oriented programming is it gives us a divide and conquer approach to development. I can implement and test the behavior of each class separately. And once I have that done, then I can start doing the whole system as a larger entity. And that increased modularity reduces the complexity of the code I write associated with any class. As a consequence, it makes it much easier to reuse the code. In fact, many Python modules define new classes inherently, and each class therefore has a separate environment. That means I don't have any collisions over the names. If I want to use a method with a particular name in one class, I can use a method with the same name in another class because they're captured inside of a module. And as we'll see a little later on, we're going to have the notion of inheritance in which we can define subclasses of classes that will capture or inherit behavior of its parent class and potentially modify it. but it makes it easier for us to write code because we don't have to write the same behavior for every class if in fact we can have it captured in a single class. We're going to take those ideas and now start to make them much more concrete.